All right, welcome. So whenever you are told to find the half-life of a reaction, be it first order, second order, zero, the third order, the only thing you need to do is to simply remember that the concentration at given time becomes equals to the time it will take the initial concentration to get to half. Simple. Once you get this idea, anywhere you see the concentration at given time, replace it with A over 2. You are good to go. You solve. Then simply like you solve the algebra. Because the idea of half-life of a reaction is simply as in what at the time it will take the initial concentration to get to half, because in every reaction the concentration tends to get to a point where it disappears to form products. So I'll replace this by this is 1, and remember what we have here, everything we have here is simply from the integrated rates law equation. So check my video on rates law equation. So 1 over A over 2 is equals to KT plus, and remember that this is concentration, initial concentration, to 1 over initial concentration. And remember that once we put this, we replace this with the concentration at given time getting to half. We need to replace the T here with T half. That is what we are looking for, not any type of T, but the time for it to get to half. So I need to replace this. So if I know this, I can clearly see that this is the sentence saying 1 divided by A naught over 2, which is the sentence saying 1 times 2 over A naught. You see it? And this is the sentence saying 2 over A naught. So once you see that what you're dividing, like it exists there, is already there, that means it's the sentence saying the numerator being divided by fraction in this case. So it's all equals to, everything is equals to, so KT half plus 1 over initial concentration. Remember, our goal is how do we make this subject of formula. So we are trying to put everything away from it. So this one crossing over, it becomes 2 over A naught initial concentration minus 1 over initial concentration is equals to KT half. So this is going to be the sentence, and look at this, they are the same. So there's no need finding LCM. The LCM is the same, so just bring it out. Initial concentration. So there's no need doing, if you carry this, divide this, is going to get out 1 times this 2 minus 1. This is something that's saying 1 over initial concentration is equals to KT half. Is equals to KT half. This thing is some people's problem, but this is very simple. So when I have this now, I can say divide both sides by K. Divide both sides by K. Let me put the division here. I have to do it this way. So you see that in this case, everything here is being divided by K. So this will cancel this, so that I have C. So I have T half is equals to 1 over initial concentration divided by K. Yes. So you can see that this is the sentence K standing on this one. So this is going to be T half is equals to 1 over initial concentration times 1 over K. Very important to note all these things. Everything here is being divided by this. So this is going to be the sentence saying 1 over A naught K. So that is T half for you. So the half-life of a second order reaction is simply 1 all over initial concentration times K. So that is it. 1 divided by initial concentration times K. So let's say they gave me maybe initial concentration to be 2 and K to be 0.1. All I need to do is to come and do 1 over 2 times 0.1. Whatever I get, that's my answer. And that should give me, let's see if we can solve it. So this should give me 1 over 0.2, and 1 divided by 0.2 is going to give me 5. So 5 seconds. So my TF is going to be 5 seconds in this kind of case. Let's say they give me this kind of question. So there you have it. So in our next class, we'll be treating half-life of a third order reaction. Thank you. Remember to like and subscribe to Academic Daddy.